Hello everyone. We are going to explore cryptocurrency today. So the very first question arises, why cryptocurrency exists? So for this you have to answer this question, that how can two strangers exchange values without trusting each other or trusting a third party? This is the entire reason why cryptocurrency was invented. Imagine you want to send $100 to your friend in some other country. If you go by the traditional way, what you will do? You will deposit your money in your bank, then there will be some international system involved. From there, it will be transferred to your friend's bank, and then from that bank, it will be transferred to your friend. So, but in this traditional way, it will cost your time, money, trust, control, privacy. Now, the question is, can we do this without banks? Can you try to send money directly? You gave your friend a message that I sent you $100. What your friend might think that how do he really know that you have sent the money? How do he will know that you didn't send that same money to someone else? How do he even know that you have $100 in the first place only? This is called double spending problem. In the physical world, if you give $100 bill to someone else, you can't give that same bill to someone else because you don't have it anymore. But in digital world, you can send the same $100 file to person A, B and C. How do we prevent this thing without a bank? Then comes the mathematical solution, which is the public ledger. Instead of trusting one person or bank, what we do, we create a public record that everyone can see. Think of it like a notebook which records every transaction. Like in page 1 we have written Alice has $100, in page 2 we have written Alice gave $100, or Alice gave Bob $50, and then Alice has $50 and Bob has $50. In page 3 we have written Alice have $50, gave Charles $50. Now Alice has $0 and Charles has $50. Now if page 4 you write Alice gave David $50, it will be rejected because Alice has $0 now. So if everyone can see all the transaction, no one can spend money they don't have. But wait, now the problem is new. If we have a public ledger, new problems appear. The problems can be, who maintains this notebook? If one person is maintaining, what if he is dishonest? If it is being maintained by some company, they might charge some fees. If it is maintained by government, they might censor some of the transactions. Second problem may be, who decide which transaction is valid? There can be another problem. How do we prevent someone from erasing the history? This is where mathematics saves us. Cryptocurrency solves these problems using mathematical proof instead of trusting the people and the parties. So the core mathematics involved is the cryptography, which is based on number theory. Then we have hash function based on information theory. Then the consensus algorithm based on game theory. And finally, we will have the distributed system, which is based on network theory. So let us explore step by step. The first step is the cryptography. How do you prove that I am Alice without showing an ID card that could be copied? Now, this is solved using public key cryptography. Some operations are easy in one direction, but they are nearly impossible to reverse. Like for example, if I tell you to multiply 37 with 83, you can calculate and you will say the answer is 3071. But it would be difficult if I give you just 3071 and I asked you to find the factors of the two number whose multiplication is 3071. In reality, we have big numbers which contain hundreds of digits, and to reverse the process, it becomes practically impossible. So what Alice will do, she will pick a huge random number which is her secret key. Actually, they contain 256 digits, the secret key. And then we use some mathematical formula to convert that secret key to a public key. So going from secret key to public key is easy for Alice. But if you have the public key, you try to reverse and go to the secret key, that is nearly impossible. So this is one step. Then Alice can also sign messages using her secret key. When Alice has to send money to Bob, what will do? She will create a message that Alice sends Bob $50. Then what will do? She will use her secret key to create her digital signature. She already has the message. She add it with her secret key, then apply some mathematical formula. It will be converted to a digital signature of Alice. Now anyone can check whether that signature is of Alice or not. We have the message, we have the signature of Alice, and everyone has the Alice public key as well. So combining this, we use a verification formula which gives the output as true or false. If the output is true, we say that this is definitely signed by someone who is having the Alice secret key. And if the output is false, we say that this is fake. So the formula used here is called the elliptic curve cryptography. I have already created a video on it. You can watch it. How do we add and multiply the points on an elliptic curve? Now, that problem is basically called as the discrete logarithm problem, which is mathematically hard to reverse the process. Now, why this problem? Why this solves the trust problem? Traditional system was, I trust Alice is who she says she is. It required trust. But in the cryptographic system, what we do is, the mathematics prove that this message has come from Alice secret key. No trust is needed. We just trust the mathematics. Moving to the second step, which is the game theory. What if someone tries to lie about the transaction? For here, what we do, we design the system such that if you are being honest, then the profit from being honest is greater than profit from cheating. Here we use Nash equilibrium from game theory. For example, you can imagine a game. If you are honest, you will earn $100, and if you cheat and succeed, you earn $1,000. But if you cheat and get caught, you will lose $10,000. And for this, if you calculate the probability of getting caught, it comes out to be 95%. You can understand with this example, if what is the exact expected value? If you are being honest, it is $100, and if you cheat, what is the expected value? It will be 5% of $1,000 plus 95% of minus $10,000, because that is you are losing, so we are using here minus sign. And so if you subtract it, you are going to lose $9,450 if you cheat. So the problem you can see here, if you are being honest, you are being more profitable than if you are being cheating. So what will be the rational choice you will have? You have to be honest. This is how cryptocurrency works. The system is designed so cheating is economically stupid. Moving to the third step, which is consensus. There is no single authority. If no one is in charge, how do we agree what is true? So here what we do is, we go with the majority consensus. Instead of trusting one person, we trust the majority. Let us understand with the help of example. If 1,000 people keep a copy of the ledger and 900 people say transaction X happened, 100 people say transaction X didn't happen, what you will do? We calculate the probability. For example, if each person has a 10% chance of being dishonest, then what is the probability that 500 plus people will be dishonest? Using probability formula, basically we use the Bernoulli's trials formula, you get the probability almost equal to 0. So what is the insight we get from here? It is easier to get one person to lie than to get more than 500 people out of 100,000 people to coordinate in the same lie. So from there, we go with the majority, because majority cannot lie, because as we have already seen, the probability in that case almost tends to 0. Putting it all together, in the traditional system, if there is single point of failure, either you or your bank, if the bank lies, you lose everything. But in cryptocurrency system rather, there is no need of trust. You have to trust the mathematics only. Correct? So this is not about money. This is about replacing human judgment with mathematical proof. Before it was like, I trust this is true. After, the mathematics proves that this is true. So there is no need of trust. There are some examples which doesn't involve money, but you can consider the cases like voting system. You can prove votes without revealing the identity. Supply chains, you can prove the authenticity without trusting the inspectors. So these are other use cases where we can use this same mathematical model to improve our working systems. So in summary, we answered the question, how can a stranger exchange value without trust? Replace trust in people with trust in mathematics. We saw 4 steps involved in this: cryptography, game theory, consensus, and public ledger. Cryptography proves identity without revealing the secret key. Game theory, it makes honesty more profitable than cheating. Nash equilibrium. Consensus, it eliminates single points of failure. We consider the majority. And public ledger, it makes all the transactions transparent. So we have a system where I believe you becomes the maths prove it. Hope you understand the video. Thank you for watching.